right, are you guys ready? We're the last presentation of the day. I have to wrap up basically everything you heard throughout the day. I got to do in the next 45 minutes. How does that sound? And so that means I will probably move really fast. I always have way too much complication in my presentations and way too many complicated demos. And actually, I will need your help at some point in the presentation, so have your phone ready. For one thing, you want to get access to this slide deck, and that's the bit.ly JNation 2019. Or you want to follow me on Twitter, so at Burr Sutter. But definitely grab access to the slide deck. I'll be able to see if you joined the live slide deck, because there's going to be tons of other information in the slides that you're going to want. So there's going to be other links and other information that you're going to want. Trust me on that. Everybody always goes, oh, I forgot to get the link. I really want the slide deck. Well, there it is. Okay, so we're going to talk about being cloud native and what it means to be a cloud native application architect. We're going to talk a little bit about what it means to do things like DevOps, but we're going to go real fast. We're going to talk about service mesh technology. We're going to talk about Kubernetes, and we're going to talk about OpenShift, and we're going to talk about this thing called Quarkus. So there's so many things I want to talk to you about today, but we have very limited time. So I'm going to focus most of my attention on what's happening within Kubernetes, which is the cloud native world, right? Cloud Native Computing Foundation, which is the sponsored organization behind Kubernetes. And we're also going to talk to you a little about Quarkus, which I had several good conversations with people at the booth earlier about how we made Java super fast and small. And I want to show you a little bit of that as well, because you'll see that play out in this presentation. But I always love doing my evolutionary slide, and this version of it, actually, I decided to go back a little bit in time and talk to people about what it meant to be a programmer in the 70s. In the 70s, you only had to learn 3 things: COBOL, and either JCL or Wiffle. JCL if you're an IBM COBOL programmer, and Wiffle if you're a Unisys Sperry programmer, workflow language versus job control language. There wasn't much more than that. You didn't have all these fancy editors and fancy tools. You just had a nice green screen terminal, and you wrote applications. In the 80s, we actually got a little more complicated. We introduced people to C and C++, maybe 4GL technology, or maybe CASE, computer-aided software engineering. This is where the software would generate software. And that worked out so well that we, of course, stuck with that, which is wrong. We did not like that at all. Maybe you guys were NetWare people back in the day. I was actually a NetWare administrator for one point in time, and people don't even know what that is anymore, right? That was the original local area network. The concept of the LAN was born back then. And of course, the relational database was born back then. So we've been thinking about how to build new kinds of application infrastructure for a long time. We have things like Unix and SQL and relational databases back in the 80s. In the 90s, it got a little more complicated. Around the mid-90s, we introduced the world not only to client server and how to build a Windows-based application, but how to use things like HTTP and HTML, about how to use things like a get or post or put or delete in the HTTP world. We had to explain to people what a cookie was. And I actually had to explain cookies to people, because I used to teach web programming principles, and I'd have to explain that the cookie is a little bit like that ear tag you put in the antelope, and that way you can track the antelope around the savannah. And it's not going to steal your credit card, because back then we were certain it was going to steal everyone's credit cards. And now we have all these warnings in our browsers about cookies. I think it's actually kind of amazing. So we also learned about Windows NT, we learned about Solaris, we learned about AIX, we learned about object-oriented programming. And then we move over to the 2000s, right? That first decade of the 2000s, and we really got into MVC with this technology called struts, so model view controller. We really got into dependency injection with this thing called Spring. We really got into this thing called ORM, object relational mapping, with this thing called Hibernate. We learned about XML, we learned about web services and SOAP and WSDL and all these other things. But you can see that the world gets more complicated as each generation has gone by. Depending on what world you grew up in as a programmer, you can see it gets a little bit harder. Now we have Linux, and then of course in the 2010s we have Angular, React, and Vue. We have Node.js, we have iOS and Android. We have IoT, Internet of Things. We have Maven versus Gradle. We have things like Git versus Subversion at this point. You might be thinking in terms of gRPC or WebSockets as opposed to just regular old REST. And of course, we only use SOAP for legacy purposes at this point in time. But you can see that the world continues to evolve. And so I just want you guys to have all this perspective, because I recognize that I'm going to shove more things into your brains in this presentation in just a few minutes that are going to continue to overflow your buffer. Okay? Because we all want to be like the Silicon Valley unicorn here. This is the GitHub unicorn. But that is an evolutionary process, and we're always on a journey, always learning, always growing. So keep that in mind. When you see this slide right here, I have the 12 major points that I would love to be able to spend the next 3 hours talking to you about, but we don't have time. But I could talk to you a long time about DevOps and DevOps principles and agility derived from DevOps, or maybe skill portability, and we'll talk more about that in a second. But also the concept of having on-demand infrastructure. So if you program professionally for any big organization, Any big government, any big bank, any big insurance company, big travel company, you probably have to ask for resources. You have to say, hey, I need a new virtual machine with this application stack on it, with this version of Linux, with this setup, so I can try an experiment. The business has come to me with an idea. I want to take that idea and run my experiment on Tomcat with Java 11, with Spring installed, with, or I want to use this version of Node.js with this version of Express. Whatever it might be, you want your stack ready to go. And whenever you've asked for that resource, you spent weeks, in some cases, waiting for that virtual machine. In a lot of cases, it's 3 weeks of wait time, or 1 week of wait time, and you have to file a ticket, and the ticket has to be signed off by a vice president. And I'm here to tell you right now, in this day and age, if you have to wait longer than 5 minutes, or maybe 5 seconds, you waited too long. We live in a world now where the cloud has made it so that anybody with a credit card can spin up resources as fast as they want to. I recently had a conversation with a person who was, I get a lot of emails from people because I go out and teach a lot of classes, and they were like, I really want to learn Linux. I really want to move into this world of Kubernetes and Linux containers and Docker, because I know that if I have those skills, it'll expand not only my resume, but also increase my paycheck, right? Because it will. These skills are incredibly high demand. So how do I only have one little Windows laptop. What can I do with one little Windows laptop? What version of Linux should I blow away Windows for and put on that laptop? Should I install Fedora? And my response was no. Keep Windows on the laptop and run all your Linux in the cloud. You can go spin up virtual machines in the cloud in about 30 seconds and have all flavors of Linux you could possibly want. And you can have a Kubernetes cluster there if you want. You can have Docker and Linux containers there if you want. You can have anything you want with no fuss, no muss, just for a few dollars a month. So hold that thought in your mind. I want you to be thinking about that on-demand, always moving, always learning. Nothing holds you back anymore, okay? Because we're going to see more of that in detail. But I'm going to try to touch on several of these principles here in this presentation. So deployment techniques. If we have time, we'll see a little blue-green. We'll see a little canary. We're going to talk about how we separate application infrastructure from application architecture, or the application itself, right? The business logic. A little bit about Linux containers, a little bit about Kubernetes, a little bit about Quarkus and what we've done with Java, and hopefully you'll see some really cool stuff here, because we will cover a lot of ground. Now, I make this point about this resource. This is online learning with O'Reilly. I teach for O'Reilly as well about every month. I'll run a 3-hour Kubernetes session, or a 3-hour Istio session, or a 3-hour serverless Kubernetes session with Knative. So you can get a lot of content. So a lot of information and a lot of education can be had for $49 a month with a Safari subscription. You have access to all the books from O'Reilly, as well as this resource here, which is online live training. So just keep that one in mind, too. Now, I love this quote by Bruce Lee: adapt what is useful, reject what is useless, and add specifically or specially what is your own. So always think about that. You are all individuals. Your skills and your resumes are going to be individualized, and they should be. And there are some common skills that we all need to have, but you should always adapt that to your way of working, what makes you the strongest, fastest developer in the room. Now, I want to take you back to 1999 for 1 second. So another history lesson. I apologize for the 70s to the 2000s. Now we're going to take you back to 1999. And in 1999, this was the most famous movie, at least for me at the time. You guys remember the opening scene in The Matrix where Trinity spun around that room and kicked the police officer? That was mind-blowing when we saw that movie in the theater for the first time, because we'd never seen anything like that before. But the reason I took you back to 1999 to give you that perspective is because this is what it used to cost to get started. We didn't have Node.js back then, right? We didn't have server-side JavaScript in a significant way. We just had Java. We built Java web applications, and it cost about $500,000 to build Hello World. So just think about that for 1 second. This is the world we lived in. I was a high-paid consultant. I would go out and teach and consult with organizations who spent the $500,000 and show them how to build Hello World. Running on those Sun machines, running with that Oracle database, running with that BA WebLogic, and oh, better yet, the IDE itself cost $50,000 just to get the programming editor. And then you had to pay the annual maintenance fee of about $80,000 a year forevermore, in addition to the upfront cost. So I want you to think about that. And by the way, that was why we waited 3 weeks for a virtual machine back then, right? You had to wait weeks for a virtual machine. Now you should wait only moments, because in the cloud, I can buy those CPUs, I can buy that memory, I can buy it for 2 cents a minute, or 2 cents an hour, or maybe 20 cents an hour. It doesn't really matter. You determine your configuration, and you can spin up very quickly and have all this infrastructure available to you instantly. Like at this very moment, I'm running probably 10 very large boxes on the internet between Azure, Google, and Amazon, just for showing you what I'm going to show you today. And I can do that very easily. And I can do that very low cost. If I decide I'm not working and I'm going to sleep or not working this weekend, I can turn these machines off and then turn them back on Monday morning. So this ability to have that on-demand infrastructure has fundamentally changed the way we think. It no longer takes $500,000 to build Hello World. It no longer takes $500,000 to get started for your idea, your brainchild, your business idea that you want to implement in code. You can do it all for a few cents an hour. Okay? Now I want to show you a demonstration at this point in time with this concept. I want to basically talk about the skill portability briefly, and more importantly, if you build your application the Kubernetes way, you can run that application across many clouds. So if you remember, I said I need your help with your phone. I need you to go to bit.ly hybrid cloud 3. All right. If you guys would, just a couple of you, it doesn't have to be all of you, but a couple of you just join me on bit.ly hybrid cloud 3. That'll pull up this user interface. And I'll just type in my name here and hit send request. And notice it says, Hola, Burr. And it's coming from AWS, all right? So Amazon Web Services. And what I'm doing is simply running the same application on Amazon, on Google, and Azure. So you kind of see it right here. Here's my Amazon version, and here's the Kubernetes/OpenShift on top of that. Here's my Google version, and this is actually running in Asia, and running in India. This one's actually running in California. And this is the Google version, okay? And then here's my Azure version. So they're my Azure VMs, and here's my Azure Kubernetes. The point of this is, once you've learned the Kubernetes skill set, it's the same exact model everywhere, okay? Now, what's behind it is interesting, right? The way Azure configures their virtual machines and how they configure their IP addresses and how do you get your SSH key is completely different than what you do at Google, and it's completely different than what you do with Amazon. I can say from firsthand experience, because I set up these three worlds, it took me about a week to figure out all those little things. How do I get the IP address? How do I map it to a domain name? How do I get the SSH key that I need? Well, do you even provide a service to give me the SSH key? Like in the case of Google, you have to spin up your own SSH key and upload it, as opposed to Amazon, where they have a service for that. So everything is different until you get to one common paradigm, which is Kubernetes, Kubernetes, Kubernetes. In this case, OpenShift is Red Hat's distribution of Kubernetes. And so it looks like I have some people join me here. Fantastic. So here's what I'm going to do. I'm going to come into my Amazon one, and I'm going to shut down the Amazon responder. So this is the worker node on Amazon that's basically responding to your request. So if I come here now and say Burr again, but I can't even spell my name, notice it's failed over to the server called Burr. Okay, so now I'm on this Burr set of servers. Let me kill Burr as well. Oh, that's not that one. Over here, I'm going to remove Burr. This has a slightly different user interface. It's a different version of Kubernetes, different version of OpenShift. But I can see now that you're going to fail over to Google. So we just failed you over from Amazon to Burr, which might be my on-premise machine, over to Google. And if I shut down Google, you'd fail over to Azure. And because I configured it that way with this basic topology, we can kind of see Burr is the hub, and Azure and Amazon and GCP, Google, are the nodes there. And we are basically moving transactions around that infrastructure. So if I come over here and basically now crank this up again, I'm going to come back on and turn Burr back on. And actually, I turned it on too, but that's fine. And let's see here. I'm also going to crank up load. So let me do that as well, so you guys can see what it looks like if it's loaded. And what this does is basically, the nice thing is it's Kubernetes everywhere. So my application code is the same. The way I configure it, everything, deploy it, the same. I can have it all scripted, and I have it. I basically shoot it out to every cloud. But what it's using to do this dynamic rerouting of transaction logic is this ability to basically use AMQP, and the Apache Cupid dispatch router. So I'll kind of make note of that, Apache Cupid dispatch router. It's this technology right here that basically allows me to now dynamically load balance across all these clouds, or across any infrastructure for that matter, using AMQP. And you can kind of see what right here, Burr is mostly processing the transactions on the Burr cloud, and not too many, there's like one that went out to Google, almost none that went out to Amazon. So basically, it's optimized to process things locally, but I want to kind of change that. Let's come over here and go back over here, and let's actually crank this down to 0 and hop back over here real fast. Okay, watch what happens. So now we no longer have processing capacity on Burr, so basically we have to move all the other transactions out to, in this case, Google, Amazon, and Azure. And you can see how it's basically decided to do that. You can see even that Burr is sending 15 transactions per second to Google, and then about 16 transactions, 18 transactions per second to Azure, and then some to Amazon. And it's doing that based on various algorithms deciding what the latency is. And of course, our application is still up over here. So if I come here and type in Burr, it should be, well, we have so many things flying through the system now. And of course, you guys are getting these same notifications on your device as well. Okay? So thank you for doing that, because you guys played along with me. And so, Mom, I'm on the screen. Fantastic. All right. So whenever you do this sort of thing, I'm trusting you guys to keep it clean, okay? Okay. But I wanted to show you that to give you a feel for what it means to running in this cloud world. I can spin up resources rapidly. I can move my application from one cloud to another, and I have this ability now to expand to a global footprint. Again, I'm running in California, I'm running in Europe, I'm running in Asia across those data centers you saw there. Just because I wanted to prove the point you can run across the entire globe. And you want to put your footprint wherever it's going to give your customer the lowest latency. All right, so that's that particular demonstration. There's a lot of cool stuff to show you yet. And I got to move a little faster here, so let's get going. So that was my idea of the fool is showing off. That was me there. Okay, so we saw that demonstration. Now, I want you guys to think about a few more things before we show you a couple other demonstrations. And I love this quote about people who are unaware they're walking in darkness will never seek the light. So the good news is you guys showed up at the conference today. You showed up here in Coimbra to learn more. And I just want you guys to understand that you represent a tiny fraction of the ecosystem of professional software developers. If there's 7 billion people on this planet who all want digital assets, digital apps, digital APIs, new digital content, there are approximately 10 million professional software developers who can deliver those capabilities, of which we have 1,000 folks here at this conference. And if you look at across the global conferences and user groups, maybe 100,000 total. So you are the elite of the elite. And so you here are seeking light. One thing you should definitely read, if you don't read it on a regular basis, is the State of DevOps report. Make sure you check this out, and so I have the link right there. This will give you much greater insight as to what's going on in the world of DevOps. You also have these books that you want to check out as well. These are phenomenal books that will teach you different things about what it means to work with Dev and Ops together. I normally have a whole presentation to deep dives on DevOps, but I want to give you that information. And I want you to think about your application for a moment. I actually talked to several people that visited us in the booth earlier, and I talked to a lot of you guys here. And I heard from people like, oh, we're all still on a monolithic application architecture, or we might be thinking about microservices. And so I want to talk to you about the application architecture for just a second. For one thing, there's nothing wrong with monolithic applications. You can deploy a monolithic application as fast as once a week. And we've seen many documented use cases that show that a monolith can go as fast as once a week. So I have a whole presentation called Teaching Elephants to Dance, which is kind of the point. Even though I have this big elephant called my monolithic application, I can still ship as fast as once a week. And that could be very important to your business. Okay? Because if you only when you ship do you learn. Only when you ship do you find out if you met customer need. So you have to ship as early and often as possible, but can you ship as fast as once a week? But what we want to do is go faster than that. And so we started thinking about the application as these individual modules, these individual components, these microservices, and our application fades into the background. The application is no longer one big ear file, or one big zip file, or one big monolithic component that has to be deployed together. It's now a series of individual components known as microservices. And what gets weird is when we distribute those microservices around a network. And we have a network call in between all these different components. That makes it much harder, because all these guys might have their own individual database. Some might have Mongo, some SQL Server, some Oracle, some Postgres, some MySQL. And they also have multiple points of entry. This is where we have an API gateway concern, API governance concern. What happens if you have multiple front doors when you used to only have one? We used to just have our web portal. Now we have this whole business-to-business API layer that has to be interacted with, and how do we manage that? This is the world of complexity we're now living in, and what gets crazier is all these individual components are deployed by individual teams that have their own individual pipeline and their own individual route to production. This team might deploy every Tuesday at 9 a.m. This other team might deploy every Thursday at 10 a.m. in the morning. And a whole different team might deploy only every 2 weeks, because that's as fast as they can go. But you can do that because you have this independent set of systems here. But you have this service mesh of technology. Okay? So these are the microservices principles, and again, we could spend like hours talking about these things. People start to know these pretty well. But the concept here is very straightforward. You have to have an API that you're married to, an API that's backward compatible, an API that you're servicing customers with, even if it's just an internal customer in your organization, and you treat it like a product, not a project. You fund it forever like a startup would. You don't fund it for the next quarter and then kill it after that. So it's a different model, funding model and organizational model than what we've had before. And these principles are incredibly hard to live by. All right, so just keep that in mind. So when people say they're doing microservices, often they're not achieving microservices. They're simply breaking up their app into a few different component parts, but it's still the traditional waterfall model, traditional monolithic model. So you can live in the old school world, but if you decide to move to this new school world, this is where something like Kubernetes really helps you. This is where going cloud native really helps you, okay? So microservices is fundamental about distributed computing. This means A calls B calls C across a network. And if you've dealt with a network connection before, or maybe the network even at this conference center, and most conference centers I go to, you'll find the network is never reliable. Latency is never zero. You will also have bandwidth issues. You're going to have all sorts of issues with the topology and with things changing. The network is fundamentally not reliable, and you put it amongst all your application components. So what happens if one of these little components in that mesh of services actually gets injured? It's too slow. It blows up. It dies. Is it a cascading failure throughout the rest of your infrastructure? And this is what you're trying to avoid. You're trying to know that you know that some things will fail. Some developer who's moving their little two-pizza team doing CI/CD and deploying every Thursday at 10 o'clock in the morning, right? They're super fast. They may fail, because that's okay in this world. Failure in production is expected, but how do you deal with that failure is really what's required of you now. So if you look at all those different things you need in this microservices world, we have categorized these things into microservices capabilities, Microservices'ilities. And you can kind of see right here, right? We have the concept of discovery. How's that managed? And you can use different libraries for different discovery mechanisms, but Kubernetes has that built in, and Istio augments it. How do you make the invocation model work? Are you using HTTP? Are you using SOAP over HTTP? Are you using WSDL, AMQP? Are you using gRPC? Whatever it is, you know, a nice thing about basic TCP stuff, the invocation model, at least over HTTP, gRPC is perfectly easy with Kubernetes. What about elasticity? How do I scale out? How do I scale back? Again, handled easily with Kubernetes, and I'll show you some examples of that. Is the call resilient? Is it resilient to failure? If that endpoint is very slow when I make that call, can I break off into a circuit breaker? And that's where Istio kind of fills in the gap. What about my deployment pipeline? Can I automate that? And I can use OpenShift integration with Jenkins as an example, and basically have that fully automated. But you can kind of see, you can go around this dial, and you have to start checking all these boxes for your application infrastructure. And the good news is, if you do this with Istio and Knative and Kubernetes, it works across any programming language. So you can kind of see right there, I have like Vertex, I have JavaScript, I have Go, Spring. It doesn't matter what it is if you do it this way. In the older world, you had to do it the Java way. Java was the only team that actually had all these key capabilities. But now everybody has them because it's part of the application level infrastructure. So let's talk a little bit about Istio, and then I want to show you Istio. And you're going to have your phone ready. I'm going to get you guys to test something. So before Istio, we had this concept of putting all this infrastructure logic in our business logic. Service discovery, service load balancing, client-side load balancing, resiliency, tracing, monitoring, all that had to be added to our business logic as additional jar files in the class path. And again, it was only for Java people. No one else had these things. There was multiple attempts in the Node ecosystem to create their own circuit breaker libraries, multiple attempts to give them open tracing capability, multiple attempts to give them, a service discovery mechanism, and some of them are okay. But it all was coming late to the party because these things were invented first in the Java ecosystem. But here's the thing that's cool about Istio. We move all of that infrastructure logic into this thing called the sidecar. So now everybody can play along. The sidecar has that logic, not your business logic component, not your service. So therefore, if you want to run the V8 runtime for Node.js, or you want to run CPython, or you want to run Go, or C++, or anything for that matter, it still works. Basically, the sidecar's job is to intercept all inbound and outbound traffic and apply its magic at the network layer, as opposed to applying it in your business logic layer. Okay? So this is what the Istio data plane and control plane look like. Just so you guys are aware of it, we don't have a lot of time to explain it in detail. I do a whole 3-hour presentation on this one diagram, pretty much. But you can kind of see we have HTTP traffic flowing in left to right, maybe gRPC as well. And we can then manipulate that traffic between your application components, otherwise known as pods. We can tweak that traffic based on different needs. So I want to kind of show you that. Okay? Let me kind of show it to you briefly. And I recognize I'm moving fast because I want to kind of show you guys a lot of cool things. But let's go here. Yeah, let's see. Let me figure out what namespace I'm in. Oh, I got logged out. This is always fun. And I don't remember what my login is. And let me see. I have it in a notepad someplace. This is one of those things where you're doing live demos and bad things happen, right? So let me think. OK. That means I'm going to be logged out over here as well. Let's see. Okay, that's happy right now, but this is not. So kubectl get pods, yeah, got to be logged in. All right, so I have a notepad here. Let's see if I can remember the OC login for this one. And is that, no, not that one. These are randomly generated passwords, so it's one of those things I can't even memorize, you know? So we're going to try this on the fly. And is it that one? No, not that one. I have all these different clusters I've created. So let's do this. You guys are seeing how the sausage is made. Let me log in. All right, kubectl get pods. Fantastic, kubectl get namespaces. And there we go. All right, so this is basically my cluster that I'm running against here. I got logged back into it. And so I've always worried that I would be logged out right in the middle of a presentation. And there it was. So what we're going to show you right now is kubectl get nodes. So this is a cluster that I have running. And so this particular cluster is running up on Amazon. It's running in Paris in this specific case. It has 7 worker nodes, approximately 7 worker nodes, and 3 master nodes. So it's a nice, robust production class cluster. But what I want to do now is, let's see if we can have a little fun with it. So I have customer preference and recommendation running. So let me go here. Let's go here to, we'll show this in the user interface so you can kind of see what it looks like here. So I have these 3 microservices running, and I want to do some things to it. So for one thing, I want to deploy let's deploy, I have a bunch of scripts that makes this a little bit easier for myself. I want to deploy a second version of recommendation. So that's being deployed out there. And if I go over here, this is the Istio customer link. So go to that one. And then you'll be able to access the same application just like you see me doing here. Let me go here and here. It'll look like this. Very simple for now. So if you guys can connect to that, what I'm going to do is show you what it means to deploy rather rapidly. So in this case, I've deployed a version 2. There it is. Version 2 just got deployed. And now you see it's load balanced automatically. So about 50% of the time, you're going to see version 1 versus version 2. Because what we're doing is we're practicing CI/CD. We're moving super fast. We're building and deploying constantly. And so with Istio, I can now do some very interesting things. So this is regular Kubernetes behavior, right? You get 50-50 load balancing because you have 2 applications running, and you kind of see what it looks like there. If I come over here now and say, watch, get pods. Okay, you can see right there that I have customer preference and recommendation 1 and 2. But now I can do something kind of fun with it. I can basically say everybody's on version 2. So if I go over here to my Firefox, you can see everybody's now on version 2. So this concept is now known as a blue-green deployment. I have blue or green, 1 or 2. And so if I want, I can come here now and say I want to basically go back to version 1. And now everybody's on version 1. If you guys refresh your browser on your mobile phone, you'll see you're on version 1 as well. So that's a blue-green deployment. And it's super trivial, super easy with regular Kubernetes or with Istio-ized Kubernetes. So with Istio-ized Kubernetes, it gets a little bit more sophisticated than that. I can do an 80-10 split. So instead of the 50-50 I had before, how about 10% of our users actually hit the new version? So you can kind of see about 1 out of every 10 times with that new version. I even have Safari over here too. On this one, let's see here. Okay, so, depending on who's getting the version 2s, we might see that. But what this means is you can also do things that are really complicated. Let me also remove those virtual services and destination rules for Istio, and you'll see we'll go back to nice round-robin 50-50. But then I want to add a canary deployment. So instead of a blue-green, which is all or nothing, I want a percentage of my user base to see the new version. So in this case, you notice you should all be on version 1, unless you're logged in on a Safari browser and you're version 2. So you can actually use any of the HTTP headers that you want. You want to use the user agent. I want only mobile users on the new version. I want only Safari users. I only want logged-in users who have checked in their profile the beta box, and they're on the new version. Only employees might be on the new version. So you can get very sophisticated with this and try some different things. You can see, again, all our users are on version 1, and you're on version 1. And then you can actually have a lot of fun with this. So I have a little curl here, but let me also remove those rules. So I'm deleting those rules, and I'll go back to nice round-robin 50-50, like that. And, okay, so we're back to 50-50 load balancing. And I can then decide, you know what? I really don't want my users to see version 2 at all. I can just delete the deployment, recommendation v2. And so, I got to spell recommendation correctly. recommendation, version 2. Did I spell it right there? And notice, again, it's basically using, again, the declarative nature of Kubernetes to say, shut that thing down. So we're all on version 1. And even Safari will be back on version 1. Or Firefox is on version 1. So that's a very simple example of the power of what you get with something like an Istio. You also get things like observability, which this console sometimes freezes on me. Come up here. That one looks OK. So the Kiali, in this case, doesn't want to run for me. I've had it freeze on me earlier today. But you can kind of see the entire service mesh. You can also see all the metrics and processing inside the service mesh. And then now you have this super clean way of doing fast cycle deployments, deploying something that might be broken into production, and then fixing it rapidly. As a matter of fact, there's actually safeguards built into this Istio service mesh so that if, in fact, that's throwing up 500s, it'll automatically route around the problem, as an example. In other words, if version 2 has bad code in it, it'll automatically route around it back to version 1, things like that. So there's a lot of things we could show you in just this one category. There's a lot of interesting capability here. But I also want to make the point that when I deploy these things, I'm deploying it using a technology called Quarkus. But it doesn't have to be Quarkus. So let me see here. I'm going to just back out a little ways and bring up my editor. Okay, so we're using these kinds of concepts here, like these little YAML files to manipulate all that. But if we look here under customer, it could be .NET, it could be Node.js, it could be Java, it could be anything. It doesn't really matter. The same principles apply. So just keep that in mind. So I've even done this with C# as an example, because C# runs nicely on Linux, and you can go in there and kind of mess around with all these pods. All right, so let's get out of there. Let me show you something else. What do you guys think of that, though? Is that interesting so far? Okay, let's do this. I want to show you what it means to actually also use something called Quarkus, which we'll talk more about in a second. And the slide deck, oh, there's Kiali, right there. So it came up for me. But I want to show you about using something called Quarkus. Because with Quarkus, we've done something very special for the Java community. And this is a brand new thing, just was born in March of this year. And we've had a lot of situations where I've gone out and given presentations on all this Kubernetes stuff. And people are like, this is amazing. I want to be cloud native. I want to move to this new world where we basically are just, putting down our credit card, launching things on the fly, basically, deploying things instantly. But I need to use Node.js or Go for that, because Java's too fat and slow. We heard that time and time again as Red Hat, and I've heard that a lot. I had many customers tell me, I would love to do all this fancy stuff you're doing, but Java's just too slow for that dynamically scalable world that the cloud looks like. And so we took that to heart. We've been thinking about this for a number of years, and what we've done with this technology is we built a Java stack for you that is faster and smaller than Node.js. I know, so this is where people start screaming. But let's show you this if we can. I'm going to start just by building a very simple project. All right, so I'm going to use this create plugin here, and I'm going to call this Burr Sutter, and let's call this the corked stuff. Just give it a name, and corked stuff. Okay, 1.0 snapshot. Give me a REST endpoint by default. That looks good. Okay. Oh, and I put it in the wrong directory. So I forgot. I got to build a directory first. Man. Okay, mkdir stuff. Get in there. Okay, same thing. Right. Come on, Burr Sutter. Stuff. Yep, one. Yes. There we go. All right, so we already have this block of code that was generated for us automatically. And if you're familiar with Java, this is very standard, except that there's one thing a little bit unique. There's 2 Docker files there, and we'll talk about those in a second. But for now, let me bring up my programming editor. And I'm always using this thing called Visual Studio Code. Visual Studio Code has been augmented for Java by the Red Hat team. So the team I work with at Red Hat kind of provided the language support for that, so that's why I use Visual Studio Code. It's also awesome for JavaScript when I'm doing JavaScript. And it's awesome for Python when I'm doing Python. But let me try this right now. I'm going to come in here to the editor, and let's look at the simple endpoint it generated for me. And I want to show you something right now that, if you're not familiar with Java, you might be thinking, that's kind of normal, because this comes from the Node.js universe. I'm going to type in one command and run it. And then I'm going to go to my browser, okay, and I'm going to hit localhost 8080. And I'm going to go to that specific hello endpoint. So there's hello. So basically, you can see the URL that I'm on, localhost 8080, hello. I'm going to go here to my code, and I'm going to call this bonjour. Hit save and refresh. Now, for those of you you should have gasped at that moment. Because you're Node.js people. You're like, that's normal. For us Java people, this is game-changing, okay? We normally would go get coffee because we'd wait for the compile to happen. So now we're living in a world where we can do things that are kind of crazy. So if I want to come here and put hola, wait, I know how to do this. There we go. That's the right one. Yeah, fantastic. So edit, save, refresh. Edit, save, refresh. Edit, save, refresh. And it kind of works out the same way if you want to do interactive testing. So if I want to come here and look at my test, there's my test. Let's run my test. So I can interactively run my test in addition to running the actual development environment. Oh, I have a failure. That's because it used to say hello, and now it says hola. So I can come here and fix that too. Let's close this. And I can say hola. And there we go, number 2. All right. And save, and then run my test again. And my test should come back green in this case. But this concept is very, very powerful. Okay? And you can also do something like this. You can actually add to it more than just hello world, because I recognize hello world is not that interesting. But you can list extensions here. And what we've done is we've optimized these various frameworks from the open source ecosystem. We've quirked them, as we call it, to make them optimized for this ultra-small, ultra-fast environment that is the cloud. So I can easily come in here and add certain things, like I might want to add Hibernate, which is very popular in the Java ecosystem. I might want to add PostgreSQL, and I might want to add JSONB for REST binding. So I'm not going to have a lot of time to show you the rest of this being built, but I want to show you one that I actually started while sitting over at the booth. If you came by earlier, you might saw me working on this. But let me show you one that I actually finished up a little bit further. Okay? So one thing is, I have this concept of the entity, and that basically is the object relational mapping component that goes into the database. To make this point, and also here's my connection parameters, I'm going to come in here now and let's do this. I'm going to come here and say add customer.java. And I want to say this is a new class. And then I want to say this is an at entity. Okay. And I want to extend Panache, Panache entity. So Panache is a very special feature where we've made Hibernate super easy to use. But I want to say public string first name. Okay. I want to say public string surname. And I'm just making this up as I go. I want the int of the age, and I want the public Boolean of if they're a customer or not, active customer or not. Okay? So I can hit save now. Let me come over here and refresh my browser. And I've turned off my dynamic reload. Let's get that going. To a Quarkus dev, right there. So look, I messed up. So there we go. We got it running again. Refresh. Connect. There we go. Now let's go check out the database here. So this is the database I'm interacting with. I want to see if this worked. So we go to refresh and tables, and now there's a customer table with the schema generated. So when I talk about you can edit the code and make changes, you also get schema changes dynamically on the fly. So your whole database application can be built by edit, save, refresh, edit, save, refresh. So I don't have to mess with customer there. I'll go look more at the to-do application I created earlier. So you can kind of see right now what to do. It has some of the basics of add, get, delete. And so if I come over here now and go here, it has a nice user interface as well. Okay, and I don't have time to finish this application, but we could show you more of it. And then love Quarkus, right? Okay, so if I come back and check out my database here, so there's to do, and I can say right-click and all rows. Okay, look, there they are. So there's our 1, 2, love Quarkus. All right, so I want to show you now what this means. So the fact that it's fast may not mean much to you. So I want to kind of show you something real quick. Let's do this. I'm going to poll, watch, kubectl, well, we got to be in the right namespace. Kubernetes to do. Yeah, watch, get pods. There we go. So it's this one right here that's basically running in the public cloud. You guys could also have access to this if you want. But for now, let's kind of try something real quick. I want to poll it, which hits a certain endpoint that tells you its host name. So again, now I can do a deployment. I can do a live deployment against it. In this case, because I only have one, I am getting errors. I should have had HA environment, but I only have one. But see what's happening right now. It's recreating that entire application in a live running system, and it's already up and running. So I just did a hot deployment of a new version of the application, and because it's based on Quarkus, it's incredibly fast, incredibly small. If I want to now make other changes to it, let's go kubectl edit deployment, and I called this one my. Dun, dun, dun. All right, so replicas, and not that replicas. There we go. Let's say we want this to be 15. So this is an aspect of the dynamic scalability you see in Kubernetes land. And you're going to see now it's spinning up 15 servers to deal with our load. So let's say I had a bunch of users come in at one time. I can start up a whole bunch of these servers very quickly. And you can kind of see now they're all active and running. And here in my little polar in the bottom screen, it's at load balance across all of them. So that concept of dynamic scalability is important in this new world. And that's why we built Quarkus, to be extremely fast and small. As a matter of fact, if I come over here and look at it, let's see if we can find it real quick. To do. This one right here. So here's all the pods running. We can look at one of these pods. And that one hasn't displayed its memory yet. And actually, let's do this real quick. If I want to scale back, I can. All right, oh, wrong one. OK. Oh. Yeah. I normally have to set up for a different editor, but in this case, it's VI. Yeah, I know, go. And I don't know VI that well anymore. It's been too long. There we go. Let's go back to 1. All right, so we're going to downscale it from 15 to 1 in this case. And then let's find that pod that we want. So here's the, see they're going to be going down. That's using 8 megs of RAM right now, but that's actually not true. It gets up to about 30 megs of RAM when it actually gets fully loaded. That one says 10. But it takes about 30 megs of RAM to run this full application. Okay, just keep that in the back of your mind. Because I want to show you one other little thing. And in the presentation, I have this concept of, we showed you kind of Microservices Istio, but I want to show you this concept of Knative as well. So this is another feature that exists in the Kubernetes ecosystem, because we don't actually want all microservices that are long running and living all the time. I want to have services that are ephemeral, services that pop in and out as needed. And so we refer to this as serverless architecture. So this is another movement happening in the cloud-native space. And the difference between serverless and microservices is you try to buy as many services as you can. You don't try to build an API gateway. You don't try to build an SSO. You don't try to build a storage or a database or a cache or a messaging solution. You try to go get them and acquire them and add them to your cluster or get them from your cloud provider. You don't actually build them. And then you build your long-running microservices, and you connect everything through these concepts of functions. Okay, so this function is something that comes and goes based on event-driven need. So this is based on something called Knative. And I want to show you that. So let's go back here and queue get pods. All right. I didn't make that change properly. You know what? We'll fix that real quick. Right here, this one. I left it at 15. I thought I made it 1. Maybe I didn't save correctly. Someone saw that I didn't hit save correctly, did I, in VI? And you guys didn't say anything. Shame on you. All right. Let me do this. I'm going to switch gears to here, and I want to show you this one little thing. Oh, side by side. Hello. So here's a simple application that uses this feature called Knative that I want to kind of make sure you guys have some insight into. And let's do this. Kubernetes, side by side. All right. Get pods. So let me do this. I'm going to basically run a script that basically sends in a ton of traffic. Notice there's no pods running. There's no computers running. There's nothing using memory or CPU at this point in time. There's nothing. But let's say I wake up at 9 o'clock Monday morning and all my users show up. I want to be able to dynamically scale based on the burst of load. In this case, it's sending 40 concurrent users at the system simultaneously. And because of that 40 concurrent users, it's decided to spin up 4 servers. In this case, you see 4 servers coming online. As soon as the first one is available, it starts responding to my 40 concurrent users. And in that case, it took about 16 seconds to get all those things in from a cold start. So we refer to this in the serverless world as cold start latency. I want to show you the same thing over here on the Node.js side. And Node.js also starts up at about the same time frame. So it's about equally as fast. OK, so let's go. While that's working. Oh, come on, Node, let's go. I've been injuring this system, so it might take a little bit longer. So it looks like 17 seconds. So a little bit lower, a little bit slower, but not much. And then let me just simply bring up my Node application. So this is my Node application responding versus my Quarkus application responding. And if I come over here and look at my Prometheus, let's hit execute, you'll see what's happening in this space. So right here, you'll see there's about 29 megs of RAM being used for this Node.js application. So we're in the 30 meg category here. And then if you look here at this Quarkus application, this one's about 16 megs of RAM. So in other words, the Java-based application, compiled to a native executable like we've done here, is actually smaller in memory footprint than the Node.js application. But the point is, you start as fast. You have the same coding model that you had before with Node.js, but now in Java, right? The edit, save, refresh. And you have the small memory footprint that you would have had with something like a Node.js to begin with. So we love Node.js at Red Hat, don't get me wrong. It's certainly been very possible, but I've had a lot of people tell me, you know what? I was about to retrain all these Java people into Go or Node or something else, and now I don't have to anymore. So I wanted to show you a little bit about Quarkus there to give you a feel for that. And so you can kind of watch it. And here's also what's cool about Knative. Because I'm not using all those servers, you'll see it's also downscaling them right now dynamically. So it upscaled them based on the burst of load, but based on my single user interacting with them, it doesn't need all those servers. So it's actually downscaling them all to one simple Node.js and one Quarkus right there. So at this point, I am officially out of time. I want you to make sure you have access to the slide deck, though, because there's all these links that'll get you access to videos, online tutorials, free ebooks. We gave away the ebook earlier at the booth, and hopefully you guys got a chance to grab that booth. But you'll get access to all this information, including resources that you want. So make sure, again, you have that bit.ly JNation 2019. At this point, did I go way too fast? But hopefully you got a feel for the different world you can live in this new cloud-native world, right? Blue-green deployments, canary deployment, super fast Java, using Kubernetes, running across any cloud, and that was kind of the point that I wanted you guys to take away. Where's Roberto, though? We have to get Roberto back up here. Oh, here he is, fantastic. And actually, I want to do one thing real quick. I want to congratulate you guys on an amazing conference. You and your team have put on an amazing event, and I think it's beautiful what you've done here for Coimbra. Look at all these folks here.
Wonderful.
And you guys are incredibly lucky to have leadership in your local community that'll do something like this for you. Not every city has that, so thank you so much.
Thank you, Burr. So Burr, Burr is actually organizing one of the best independent conferences in the US called DevNexus, right?
Well, I'm the founder of DevNexus. I no longer organize it.
Okay, but
yeah.
you still help, right?
Yes.
So if you happen to go to the US and to go to Atlanta, go to that conference. It's wonderful. I've been there a few times, and I really love it. And Burr, thank you so much for coming to the event. And you guys, as Red Hat, it's been a tremendous amount of work for you to come here in Portugal with all your team, especially because you don't have an office here in Portugal.
We came from a long distance.
Yes, exactly. But you see all of these developers over here, so maybe you can open a Red Hat office.
Exactly.
Right over there.
We need to hire a bunch of Red Hat engineers here in Coimbra, right?
Yeah.
All right, well, thank you so much.
Thank you so much.